Speaker का problem.
सर महमूद मीटिंग में है लेकिन उनका माइक काम नहीं कर रहा है।
अच्छा, आप क्या अभी अब क्या नाम है आपका?
मेरा 039 है सर रोल नंबर।
अच्छा ठीक है, 039 ओके। 039 में आपको ना ग्रुप एडमिन बना रहा हूं। आप
ओके सर।
आप थोड़ा मीटिंग देखिए।
ठीक है सर।
You are the host now.
ओके
Oh. Okay, let us continue. So what is beta function? You see, I am writing the definition. Right. The beta function is denoted by beta function of m comma n. Beta of m comma n, where m is greater than 0, comma n is greater than 0, and defined by a definite integral. See, what is the difference between integral and definite integral? Tell me, what is the difference between definite and indefinite integral?
Limits are given in definite integral.
Very good. So when the limits are not there, means that's integral only, indefinite integral. When the limits are there, that is a definite integral. So the value of this beta function will be defined with this integral, with this definite integral. Here we can write it as, I'll write with okay, beta of m comma n is equal to see, I am just using a special curve here to represent beta. Don't write simple b, we'll just move on this part. So to understand that it is beta of m comma n is equal to 0 to n, 0 to 1, x to the power of m minus 1 into 1 minus x whole to the power of n minus 1 into dx. This is the definition of beta function. Okay, and here the condition is same again. M should be a positive and n should be a positive. The beta function is denoted by beta of m comma n, where m is greater than 0, n is greater than 0, and defined by a definite integral. Beta of m comma n is equal to integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 into dx. This is the beta function. Now we have different properties of beta function. So first properties, we'll write this, heading is properties. In this properties, the first property is beta of m comma n can also be written as beta of n comma m. It means that if you change here in place of m, if you write n also, and if you replace in place of n m also, there will not be any effect on this definition. That is called symmetry property. This is the first property of beta function. Understand? Give me the answer, please.
Yes, sir.
Now, second property of the beta function is in exam they will ask the properties also. We are going to have a proof also, this one. Beta of m comma n, second property of beta function, beta of m comma n is equal to integral 0 to infinite x to the power of n minus 1 whole divided by 1 plus x whole to the power of m plus n into dx, which can also be written as, also we can write it as same thing, integral 0 to infinity x to the power of, we can change the variable also, means in place of n we can either write it as m also. Just now we have shown the symmetric property, so changing of the constant m and n will not affect our problem. M plus n here into dx. Irfan, do not allow other students, okay, those who are not concerned with CSC branch. Understood? So these two properties, actually we have one more also, third property. This one, third property also I am writing here. Third property of the beta function, that is beta of m comma n. Beta of m comma n is equals to, beta of m comma n is equals to 2 times of 0 to pi by 2 sin theta whole to the power of 2m minus 1 into cos theta whole to the power of 2n minus 1 into d theta. 2m minus 1 into 2n minus 1 into d theta. This is the third property of beta function. Now I am going to prove one by one all these three properties. Okay? Any doubt in this till now? Any doubt in this?
No, sir.
Okay. Let us prove the first property of beta function now. See, I am going to prove all these three properties. Later on, these properties will become the formulas. Understood? Beta functions के formulas बन जाते हैं बाद में. Beta of m comma n is equal to beta of n comma m. So using this symmetric property we are going to prove. ठीक है ना? Now you see the proof. So what is that? You see, we are applying the definition by definition of beta function. By definition of beta function, give me the answer. What is the beta function definition? By definition of beta function, give me the answer. Come on. Beta of come on, m comma n is equal to, come on बोलिए, integral
0 to 1
x to the power
of m minus 1
into
of
1 minus x
1
whole to the power of n
minus
minus
1
1 into dx. This is called it as equation number 1. Okay. Now what we are going to do it here in integral, you have one formula here. I am writing that formula also. Intermediate definite integral, I think you remember this formula. Integral 0 to a f of x dx. Integral 0 to a f of x dx can be written as integral 0 to a f of a minus x into dx. Can we write like this? You know the formula? Definite integral का formula है ना? Intermediate second year definite integral. Integral 0 to a f of x dx can be written as integral 0 to a f of a minus x into dx. I am going to use this formula here in equation number 1. It means that wherever x is there, we can write it as a minus x. Our a value is 1. So the above function I am writing यहाँ पे, here I am going to change. In place of this x I am writing 1 minus x. Even in place of this x also, what I am going to write? 1 minus x. Okay. Yes. Okay.
Yes, sir.
Okay. Now you see, I am using the next page to continue this. Okay. So I am continuing this problem now. If I am continuing the same problem, beta of m comma n is equal to, after replacing that values, it will give you 0 to 1. X can be written as 1 minus x according to the formula. 1 minus x to the power of m minus 1 must be as it is. And there is a bracket here, so we should write as it is. Now 1 minus, again x can be written as 1 minus x only. Okay. And then whole to the power of what we are having here, n minus 1 into dx. Right. Which can be written as integral 0 to 1. This 1 minus x, I am not going to change. This one will be as it is. M minus 1 will be as it is. This is the bracket 1. If we operate with minus sign, minus into 1, minus into minus plus x, and whole to the power of, we have n minus 1 into dx. Now we know that plus 1 minus 1 will be, cancel it out. This can be written as integral 0 to 1 minus x whole to the power of m minus 1 into what we are getting here, x power n minus 1 into dx. So this also can be written as integral 0 to 1 x to the power of n minus 1 into 1 minus x whole to the power of m minus 1, that we have proved. You see, this is the value of beta of m comma n. Definition के हिसाब से what will be the change? Where is the change? You see, m की जगह क्या आ गया यहाँ पे? What we got it? Tell me.
जगह पे x आ गया, n की जगह पे 1.
It is the value of n comma m now. Yes, obviously. So we have proved the first property of beta function. Therefore, beta of m comma n can be written as is equal to beta of n comma m. This is called symmetric property of beta function. We have proved the first property. Very, very important properties we have to use as a formula. So this is the first property we proved. Immediately copy ke lijiye, we'll go for the another one. Second property we have to prove. Second property of beta function. Can you tell me what is the second property? Second property, what we have to prove? Beta of
m comma n.
Very good. Beta of m comma n is equal to what we have to prove? Integral 0 to infinite. Integral 0 to infinite x to the power of m minus 1 whole divided by 1 plus x whole to the power of m plus n. देखिए मैं बार बार बोल रहा हूँ, we have to use these properties as a formula. Okay, or options I am not writing, which can also be written that another format, that I am not writing. If you want, I can write it. That also I will write it better. That is one more. We can change it as x to the power of n minus 1 also, because just now I shown the property of symmetry. It means that if you change the variables m and n, if you replace, there is no effect on the problem. So this is our second property. It is very important, boss. ये एग्जाम में बहुत बार पूछा है. Beta of m comma n is equal to 0 to infinite x to the power of m minus 1 by 1 plus x whole to the power of m plus n. Now I am going to write the proof. So the proof of the second most important property. Every time we can take the help of the beta function definition only. By definition of beta function, by definition of beta function. You remember, याद हुआ definition? Beta function, beta of m comma n is equal to, beta of m comma n is equal to, come on, give me the answer. Come on,
integration of
0 to 1, come on, x to the power of m minus 1 into 1 minus x whole to the power of n minus 1 into dx. This is the equation number 1. This property only we have to, definition only we have to use to prove our property. Okay, na? So now for this proof, you see what will be the difference. X power m minus 1, we required x power m minus 1 will be there. Now actually to prove this 1 plus x value in this denominator, we have some special type of substitution. अपने को denominator कुछ ऐसा 1 plus x format के जैसा assume करके proof करना है. So what we are going to do it here is, you see, in this all properties of beta functions and gamma functions, you should remember your substitution part actually. That is most important. Substitution part. Put. What we are going to put, you see, in our substitution part, in place of this, actually x power m minus 1, we got it already. We required only the denominator. So for that purpose, what I am doing here is put x is equal to 1 by 1 plus y. 1 by 1, ये 1 plus x के जैसा denominator बना रहा हूँ मैं, 1 plus y. बाद में variable change कर ली. Okay. Now, when we differentiate, what is the differentiation of x? It will be dx. And what will be the differentiation of 1 by 1 plus y? Differentiation of 1 by x is minus 1 by x square, no? Minus 1 by x square means 1 by 1 plus y whole square and dy. This is the special substitution and we are differentiating now. After this one, we have to change their limits also. For my convenience, what I am going to do it here is to apply, actually to change the limits. इसको थोड़ा सा format change कर रहा हूँ मैं इसका. If you take the reciprocal of this, it will becomes 1 by x. It is equal to, if you take the reciprocal of this, we will get 1 plus y. Now change the limits. Lower limit. What is the lower limit? In place of x, we have 0. So if you put 0, 1 by 0 is what? Undefined. Which means that if you put x value is 0, your y value is also becomes, if this is infinity, this is also infinity. This is the lower limit, upper limit. Upper limit. In place of x, if you put 1, so 1 by 1 is 1. 1 is equals to 1 plus y, like that we will get. 1 is equal to 1 plus y plus 1 cancelling on both sides, which means that y becomes 0. So where is the change? Lower limit becomes infinity, upper limit becomes 0. If you apply this special substitution, this one. Okay. 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 Give me the answer. Hello.
Yes, sir. Understood.
Okay. So next page पे जा रहा हूँ मैं देखिए. Okay. So we'll use these substitutions. Okay. Now continuing. Next page. Next page I am continuing now. So when we apply these substitutions here, when we apply, so this beta of m comma n becomes, can you see this screen?
Yes,
Lower
sir.
limit infinity to upper limit is 0. And then in place of this 1 plus x value is 1 by 1 plus y. So we are going to be writing 1 by 1 plus y in place of x 1 by 1 plus y whole power m minus 1 as it is into 1 minus 1 by 1 plus y whole to the power of n minus 1, where we are writing these values in place of beta function actually, and then our dx value will be minus 1 by 1 plus y whole square into dy. If you simplify this, because of this minus sign, we can change these limits. I'll write the formula also for your convenience. Integral a to b f of x dx. Integral a to b f of x dx can be, we can sweep like this the limits from b to a f of x dx. Now because of this minus sign, I'm going to change swiping of the limits here. That will be equal to from 0 to infinity. Okay, and 1 to the power of m minus 1 means 1 only, and denominator will be same, 1 plus y whole to the power of m minus 1. Okay, and then you see if I am taking the LCM here, LCM will be what? 1 plus y will be our LCM. 1 za means you will get the same thing, 1 plus y, and this is minus 1, and the whole power is n minus 1 here, into minus already way of swiping that 1 by 1 plus y whole square, 1 by 1 plus y whole square into dy. Now the same story again, n minus 1 power we apply for numerator and denominator, as well as plus 1 minus 1 signs are cancelled here, 0 to infinite, 1 by 1 plus y whole to the power of m minus 1, okay, into y to the power of n minus 1 as it is, y to the power of n minus 1 as it is, denominator 1 plus y whole power n minus 1. I am applying this power for numerator and as well as for denominator, n minus 1 into 1 by 1 plus y whole square, 1 by 1 plus y whole square into dy. Now if you notice, all the denominators are same now. All the denominators are same.
Sir, that's 1 plus y.
1 plus y whole square, na? Oh, sorry. It's plus now. All are plus. So denominator, all denominators are same now. All denominators are same.
Yes.
When the bases are equal, power should be added. So what happened? M minus 1 plus n minus 1 plus 2. This numerator y power n minus 1 also here as it is, and then dy as it is. What happened? This minus 1 plus ye cancel it out. So beta of m comma n is equal to, beta of m comma n is equal to what we are getting here is 0 to infinite, 0 to infinite, y to the power of n minus 1 divided by, what is left off here? 1 plus y whole to the power of m plus n is left off. M plus n into dy is left off. Now I gave the formula in the first class only, means when we started the class, integral a to b f of x dx. If you change the variable also with y also, no problem at all. Indefinite integral problems, if you change the variable also, no problem at all. F of x dx को f of y dy भी लिख सकते हैं आप. So then finally, this our beta of m comma n we are getting as beta of m comma n is equal to integral 0 to infinite. In place of y, if we replace with x, x power n minus 1 and divided by 1 plus x whole to the power of m plus n into dx. For our convenience, we can also return this one as 0 to infinite x power. We can change the variable also, m minus 1 by 1 plus x whole to the power of m plus n into dx. This is the proof of the second property of beta function. Okay, so second property is also completed. I think we have a very less time. 6 minutes are there. Third property, देखिए third property भी देख लीजिए आप. Third property, let me finish it. 6 minutes में होता होगा, देख लीजिए. Beta of m comma n, third property. What is that third property? 2 times of 0 to pi by 2, 0 to pi by 2 sin theta. हमारे क्या नाम बोले अभी आप? इरफान ना? इरफान, can you hear me, Irfan?
Sir, that's shape, sir.
ओके, वो कोई भी रहने दीजिए. आप यहाँ पे CSE के कितने स्टूडेंट्स अभी आपकी क्लास में प्रेजेंट है? उनका मेरे को एक पेपर पे लिख के अटेंडेंस भेजाइए. ओके, स्क्रीनशॉट से मेरे को अटेंडेंस रजिस्टर में भी डालना है. एंड निशात फातिमा, यू आर आई थिंक प्रेजेंट, इज देयर? CSE के कोई है क्लास में? CSE any students are there?
Yes, sir.
हाँ, आप CSE के एक पेपर में लिख के अटेंडेंस भेजाइए कोई तो भी. CSE any student?
यस सर.
कौन है, नाम बोलिए.
सर इब्राहिम.
हाँ इब्राहिम.
148.
हाँ इब्राहिम, आप भी क्या करिए, CSE के स्टूडेंट्स कौन प्रेजेंट है उनकी अटेंडेंस लिख के भेजाइए.
ओके.
देखिए मैं थर्ड प्रॉपर्टी भी कर दे रहा हूँ, इसीलिए साथ में आप लोग अटेंडेंस भेजा देते बोलते हो जाता. फिर यहाँ पे भी आपने को वी हैव टू यूज द सेम डेफिनेशन ऑफ बीटा फंक्शन. बीटा ऑफ m comma n is equal to integral 0 to 1 x power m minus 1 into 1 minus x whole to the power of n minus 1 into b. This is actually what definition of equation number 1. So now you see what is the difference. In place of x we have sin theta. अगर अपन x प्लेस पर sin theta रखे तो खाली m minus 1 आता, अपने को 2 भी चाहिए. So better we'll put like this. Put x square is equal to, put x is equal to sin square theta. Put x is equal to sin square theta. And if you differentiate, dx is equal to sin square theta differentiation is 2 sin theta into cos theta into d theta. Into d theta. So now when we have to change the limits, x is equal to sin square theta is there. Sin square theta, if you change the lower limit if you put in place of x, if you put 0, you will get a theta value also 0. In our upper limit, if you put in place of x is equal to 1, So 1 is equal to sin square theta, then theta value is equal to 90 degrees, that is pi by 2. So our beta function becomes beta of m comma n is equal to, this is 0 to pi by 2. 0 to pi by 2. In place of x, we are assuming as sin theta. So it is sin square theta whole to the power of m minus 1 into, here in place of this again 1 minus sin square theta, 1 minus sin square theta whole to the power of n minus 1 into dx value we have 2 sin theta into cos theta into d theta. Okay, so now 2 is a constant, pulled it out, 0 to pi by 2. Okay, now you multiply this power with this power, we will get sin theta whole to the power of what? 2m minus 1. Here one step I want to skip. 1 minus sin square theta is cos square theta, and with that square if you multiply, you will get cos theta whole to the power of, actually here you will get 2m minus 2, and here also 2n minus 2 into 2 already outside into sin theta into cos theta into d theta. Now you see bases are equal, power should be added. So when we add the powers, beta of m comma n value, finally we are getting 2 times of 0 to pi by 2 into sin theta whole to the power of 2m minus 2 plus 1. So we are getting 2m minus 1 into cos theta whole to the